Good morning, my dear friends. See now, today we'll begin with another this thing now problem. I will read it now. A beam of rectangular section 150 mm by 300 mm deep is used as a cantilever over a span of 4 meter. In a sense, it's a cantilever. Okay, as you see, its span is 4 meter and it has got dimensions of 150 mm by 300 mm. So I can easily write YT as 150, YB as 150. Am I right now? So YT and YB are fixed. Okay, and also he says that it is pre-stressed with 4 cables of 7 mm 5 carrying a total pre-stress of 300 kilonewton. Okay, in sense now 4 cables have been placed of 7 mm 5 and it carries a pre-stress of 300 kilonewton. Okay, placed at an eccentricity of 60 mm from the top. See now here he has kept the cables. Okay, cables are now here from the top. He has kept it at 60 mm from the top. 60 mm from the top he has kept it here now. Okay, so now CGS is here. Am I right now? 60 mm from the top, CGS is there. So now CGC is now here. So this is the eccentricity. Am I right now? I think you can easily calculate this eccentricity because it is 150 mm minus 60 mm will give me 90 mm as my eccentricity. Am I right? It can be easily calculated. See now. It is subjected to 2-point loads of 40 kilonewton each at the free end and at 2 meter from the fixed end. In a sense, he has applied here 2-point loads. One is at the free end 40 kilonewton and another one at again 2 meter from the fixed end, again 40 kilonewton. 2-point loads have been now applied. Okay, calculate the maximum stress in concrete and sketch the stress distribution. Okay, so he has asked you to sketch the maximum stress in concrete. Okay, so with this data, so we shall begin with, I think as I already said you, the eccentricity can be now easily calculated. Okay, as I said, it is 150 minus 60 will give me this eccentricity. This is the eccentricity. Okay, so E is 150 minus 60, 90 mm. And since CGS is above CGC, I will assign plus sign to it. Okay, this is one important thing. So area can be now easily calculated. It is 150 by 300 mm. Okay, moment of inertia also can be now easily calculated. It is 150 in sense BD cube by 12. Okay, and YT is plus 150, YB is minus 150. Okay, so now we will try to now calculate another important thing. Okay, dead load UDL. In sense, we will try to calculate the dead load of this beam which is acting as a UDL or the self weight. Okay, so it can be now easily calculated. It is a 0.15. In sense, its cross-sectional area is 0.15 into 0.3. Am I right? 0.15 into 0.3 into 1 meter along the span. Okay, this will give me the volume into density of your concrete will give me 1125 Newton per meter as your dead load UDL WD. Okay, so here you can show this as UDL here now, and this UDL sulfate's intensity is, it is now 1125 Newton per meter. Okay, so now, but now we'll try to find out. See now, what he has asked here is now you have to calculate the maximum stress. Here I will read now. Calculate the maximum stress in concrete and sketch the stress distribution. Baba, maximum stress will occur in case of your cantilever beams. Okay, sir, now maximum bending moment will occur at the fixed end. Am I right now? So since maximum bending moment will occur at the fixed end, so maximum stress also will occur at the fixed end only. Am I right now? So I have to calculate the stresses at the fixed end. He has not asked you to calculate the stresses at mid span. No. Okay, he has asked you to calculate the maximum stress. So maximum stress will occur at the fixed end. So now we will try to calculate the bending moment at this fixed end. Okay, so now I think it can be now easily done. Maximum bending moment at the fixed end is now, okay, I think you can easily do it. See now, it is this 40 kilonewton load into 4 meter. Am I right? again 40 kilonewton into 2 meter, okay, lever arm, force into lever arm plus force into lever arm plus you have got UDL. UDL's intensity, you know, it is 1125. Am I right? So I have written here now, maximum bend moment at the fixed end is now 40 kilonewton, means it is now 40,000. 40,000 into 4 minus 40,000 into 2 minus, okay, 1125. 1125 into 4, okay, 1125 into 4 will give me the total load, and it is acting at the center. Its lever arm is 2. Am I right now? So it is 1125 into 4 into 4 by 2, okay, will give me the bending moment at the fixed end. So it is minus 249000, because according to this sign convention, okay, this BM in sense of the ending moment sign convention is like this. So it works out to be minus, okay, bending moment is now minus in case of your cantilevers. So now once I know everything, I think you can easily start calculating the top fiber stress FT. Okay, top fiber stress FT can be now easily calculated. It is F by A plus or minus FE YT by I plus or minus MD YT by I plus ML YT by I, or I will add them up, MD plus ML YT by I, okay, because you have calculated the bending moment here by adding ML and MD and ML, okay. So MD plus ML YT by I, Baba, all the values are known to you, okay. So F you know, precessing force, okay, area you know, again F is known, eccentricity is now plus 90, okay, YT is now, since it is above CGC, plus 150, and moment of inertia you know, okay, and bending moment M is now minus, because it is in the cantilever, okay, again YT value you know, and I value you know. So you can easily calculate the value as minus 92.16 Newton per mm square. So it is minus sign indicates that it is tension, okay. Similarly, bottom fiber stress FB can be now easily calculated, okay. The same equation I can write it as now F by A plus or minus FE YB by I plus or minus MD plus ML YB by I, okay. So all the values can be now easily filled up here now, okay. So now the only change is now YB is now minus 150. YB is minus 150, okay. So this value works out to be plus 105.48, plus sign indicates that it is compression. So now here you have got FT value, here you have got FB value. I think you can easily draw the stress distribution diagram. FB is now minus 92.16, minus 92.16, and FB is now plus 105, plus 105 point this thing, okay. So you can draw the stress distribution something like this, okay. That is how you can solve this problem. Thank you very much.